Okay, have you ever asked an AI the exact same question twice and gotten a completely different answer? It can feel a little weird, right? Well, today, we are going to pull back the curtain on that whole mystery. We're going to talk about things called samplers and temperature and how they control AI responses. And you'll see how what seems totally random is actually something you can predict. Let's dive in.
So, picture this. You give the model a prompt, you run it, and boom, you get a great result. Awesome. But then you run that same, identical prompt a second time, and you get something totally different. So what's going on here? This is probably one of the most common things people run into, and honestly, it can be super confusing.
Right, and that experience can make the whole system feel, well, unstable, almost like it's got a mind of its own. But what if I told you that behind all that seeming randomness, there's actually a predictable mechanical process at work? What if you could know exactly why the output changes?
Okay, so this is the absolute key to understanding all of this. The variability you're seeing, it isn't coming from a change in what the model knows. The model's knowledge isn't shifting around between your prompts. Nope. The difference comes from something called the sampler, and that's all about how the model explores and presents that knowledge back to you.
So what is a sampler, anyway? Well, you can just think of it as the mechanism that picks the very next word, or token, from a whole list of possibilities. At every single step of generating a response, it's looking at a probability distribution of potential next words and making a choice. It's basically a selector.
And one of the biggest, most important dials you can turn on that sampler is a parameter called temperature. It might sound a little strange, but this one setting has a huge impact on the final output that you end up seeing. So let's break down how it works.
It's actually a pretty straightforward relationship. If you set a lower temperature, you're narrowing the field of possible next words, making the system a lot more focused. A higher temperature does the exact opposite. It widens that field, opening the door for less common, maybe more surprising word choices.
Now, take a look at this. This chart shows you exactly what a low temperature does. See how that one bar is way taller than the others? That means the sampler is super likely to pick the single most probable token, the obvious next choice. The result? You get an output that's more predictable, more focused, and yeah, often a lot more repetitive.
And here you can see the total opposite. With a high temperature, the probabilities get kind of flattened out. All of a sudden, those less likely words have a much better shot at getting picked. This is what leads to more varied, more diverse, and sometimes really unexpected outputs. The system isn't changing its mind, it's just exploring a wider range of what's possible.
Now, temperature isn't the only dial we can turn. You've also got parameters like top K and top P that help control the output. Top K just limits the AI to, say, the top 10 most likely next words. And top P selects from a pool of words that add up to a certain probability. Just think of them as more tools in your toolkit for managing that variability.
Okay, if you remember one thing from this, let it be this. Turning up the temperature doesn't make the system smarter. It doesn't give it new capabilities. These are just mechanical controls. All they do is shape the statistical variability of the output. They do not add new knowledge.
So let's connect the dots between how we feel about an output and what's actually happening. When a response feels really creative or novel, chances are that's just a high temperature setting. If it feels unstable and unpredictable, it could be that the sampler settings are just changing on you. And if it feels super repetitive, well, that's a classic sign of a low temperature.
And why does this matter so much? Because a lot of the platforms you use adjust these sampler settings for you automatically, depending on what they think you're trying to do. So you could be using the exact same model with the exact same prompt and get totally different results just because the platform decided to tweak the temperature in the background without telling you.
So we're really moving from a world where all this variability feels completely random and kind of magical to a world where it's actually predictable. The minute you understand the role of the sampler and its settings, you can start to anticipate and even control the kind of output you're going to get. It's no longer magic, it's just mechanics.
And that leaves us with one final and I think pretty powerful question. By understanding these controls, you've really gone from being a passive user to an active operator. You have the mental model now to understand how this system behaves. So, knowing that this variability isn't random, that it's actually controllable, what are you going to build with?